Hi, this is Mrs. Rodriguez, your Algebra 2 math teacher. This video is a review for the Chapter 5 test that's coming up very, very soon. So what I recommend that you do is as you watch this video, once a problem comes up, pause the video, try to solve the problem on your own. Once you're finished solving it, continue to play the video. If you get the correct answer, great. If not, make sure you try to figure out what your mistake was so you can identify your mistake and you don't make that mistake on the test, and then move on to the next problem. If you can't figure out your mistake, call me, text me, or email me, or stop by my office hours. I'll be happy to help you. Okay. All right. And then once you feel comfortable with the problem, then move on to the next problem. Remember, I picked these problems specifically because you're going to see problems like this very similar on your test. Okay. So some of them are from a practice test, and then some of them I added to the practice to this review because you will have problems like that on the test. Okay. All right. So here we go. Share my PowerPoint with you. So like I said, this is Algebra 2, the Chapter 5 test review. This is a practice test on page 377 of your textbook. Okay. All right. So a couple of key concepts here for operations with polynomials. To add or subtract, you can combine like terms. To multiply, you use the distributive property, and to divide, you use long division or synthetic division, okay, when you're dealing with polynomials. So here it says to simplify each expression. This is an additional practice problem, so you will definitely have one like this on the test, okay? So I'm going to multiply here. -4 times 5 is -20. Then I have a cubed times a. Remember, there's an exponent of 1 there, so I add the exponents, so that's a to the 4th. And then I have b to the 5th times b to the 3rd. So I add my exponents and I get b to the 8th power, and that is my final answer. Okay. All right, now here you're supposed to simplify. So what you need to do is separate these into separate terms, okay? So we've got 12x to the 4th, y to the 5th over 4xy to the 5th, plus 8x cubed y to the 7th over 4xy to the 5th, minus 16y squared y to the 6th, 16x squared y to the 6th over 4x y to the 5th. Okay, I'm go ahead and change colors here. Okay, so each individual one of these I'm going to simplify. So 4 and 12 have a common factor of 4. 4 goes into 4 once, 4 goes into 12 3 times. X to the 4th over x, they have a common factor of x to the 1st power, so this ends up being 1, and this ends up being x to the 3rd power because I subtract. Remember, there's an exponent of 1 here, so I subtract those exponents. And then y to the 5th over y to the 5th is just 1. So what I'm left with is 3x cubed over 1, which is just 3x cubed, okay? Then over here, 8 and 4 have a common factor of 4. 4 goes into 4 once, 4 goes into 8 twice. X cubed over x, remember there's an exponent of 1 there. They have a common factor of x, so x goes into x to the 1st power once, x goes into x cubed once, so I'm left with x squared. And then y to the 7th over y to the 5th, they have a common factor of y to the 5th, so that goes in once. And then here I'm left with y squared. So I end up with 2x squared y squared over 1, which is just 2x squared y squared, okay? And then over here, 4 and 16 have a common factor of 4. 4 goes into 4 once, 4 goes into 16 4 times. And then here, x to the 1st and x squared have a common factor of x, so I'm left with 1 here, and I'm left with x here. And then here I have y to the 6th over y to the 5th. They have a common factor of y to the 5th, so this is 1, and I'm left with y over here. So I have minus 4xy over 1. So that becomes minus 4xy. And this is my final simplified answer. Okay? A lot of simplifying on that one. Okay, so here it says to simplify each expression. So again, I'm going to be, there's no operation symbol here. I'm going to multiply. So I have to multiply m by each one of these terms. Okay, so m times m squared, that's going to give me m cubed. M times negative 2m p is going to give me 2m squared p. And then m times p squared is going to give me mp squared. Okay, and then I also need to multiply p times each one of these terms. So I have p times m squared, so that's a positive 2m squared p, and then p times minus 2mp, that's going to be minus 2mp squared, and then p times p squared is going to be p cubed. Okay, now I need to find some like terms that I can combine. So I have negative 2m squared p plus 2m squared p. Okay, well, negative 2 Okay, sorry about that. I think I messed up on this one here. So let me clear this. So this is right, 2m squared p. Okay, this is right. Okay. So let me go back to here with p. So p times m squared is going to give me positive m squared p. And then p times minus 2 mp squared, and then p times p squared is going to give me p cubed. Okay, so now when I go for looking for my like terms, I have negative 2m squared p and plus m squared p. Now remember, there is a 1 there. So negative 2 plus 1 is going to give me negative 1m squared. Okay, so I still have this m cubed, and then this is going to be negative 1m squared p. Okay, and then here I have positive 1 mp squared minus 2 mp squared. Okay, so 1 minus 2 is going to be negative 1 mp squared, and then I still have this p cubed. Now notice these are different. They look very similar, but they are not. Okay, they are not like terms. Here the base m is being squared. Here m is not being squared. P is being squared. So we cannot simplify any further. So that is our final answer. Okay. All right. So then here we're going to use the FOIL method. So I'm going to multiply 7x times 2x. That's going to give me 14x squared. And 7x times 5 is going to give me 35x. And then here I'm going to multiply negative 2 times 2x. That's negative 4x. And negative 2 times 5 is going to be negative 10. I'm going to combine like terms. I have 35x minus 4x is 31x. And that is a positive 31x. And I still have my 4x squared and my minus 10. And that is as far as I can go. Okay. All right. Next here, now here we have this subtraction sign. Okay, so we have to distribute that subtraction sign to each one of these terms. Okay, so nothing happens to 2x squared plus 3x minus 4 yet. So then I have to multiply negative times 4x squared. Well, that's negative 4x squared. And negative times negative is going to be positive 7x, and negative times positive is negative. Now I need to see if I have any like terms that I can combine. Okay, so I've got 2x squared minus 4x squared. So I'm left with negative 2x squared. And then I've got 3x plus 7x. Well, that is 10x. And then I've got negative 4 minus 1. Remember to add the opposite. Negative 4 plus negative 1 is negative 5. And that is as far as I can go. Okay. All right. So now here it says to divide. So I'm going to use long division here. So this is x plus 3. And then I'm dividing that into x to the 4th power plus 5x cubed plus 3x squared minus 8x plus 3. Okay. And I'm just going to change colors here. Okay, so I have to decide x times what is going to give me x to the 4th. Well, x to the 3rd times x is going to give me x to the 4th. So over here, I'm going to do x to the 3rd, or x cubed, times x plus 3. Okay, so I have to distribute here. So this ends up being x to the 4th plus 3x cubed. So that's here. Okay, x to the 4th plus 3x cubed. Remember when you would do long division in elementary school? Okay, you have to multiply this here by your divisor, and then you put that under here, and then you subtract. Okay, so I'm going to subtract x to the 4th, and I'm going to subtract 3x cubed. So x to the 4th minus x to the 4th, well, that's 0. And 5x cubed minus 3x cubed, that's 2x cubed. I'm going to bring everything down. Remember that from elementary. Bring it down. Okay. And then now I have to decide, okay, x times what is going to give me 2x squared. Okay. So, I'm sorry, 2x cubed. So it's going to be 2x squared. So I have to do 2x squared times x plus 3. So again, I'm distributing. 2x squared times x is 2x cubed, which is exactly what I wanted. And then 2x squared times 3 is going to be 6x squared. So that goes down here, 2x cubed plus 6x squared. And remember, I am subtracting this, both of these terms. So 2x squared minus 2x squared, well, that's 0. 3x squared plus negative 6x squared is going to be negative 3x squared. Okay, and then I bring down minus 8x plus 3. Okay, so now x times what is going to give me negative 3x squared? Well, that's going to be negative 3x. Okay, so I have to multiply negative 3x times x plus 3. See what I get here. Negative 3x times x is negative 3x squared, which is what I wanted. And then negative 3x times 3 is negative 9x. And then that goes under here. So negative 3x squared minus 9x. Now remember, I'm subtracting this, but this is negative. So that they're going to become the opposite. Okay, so now it's negative 3x squared plus 3x squared. Well, that's 0. And negative 8x plus 9x is 1x plus 3. Well, x plus 3 goes into x plus 3 exactly 1 time. And I multiply that out, and I have a remainder of 0. So my solution is what is up here. X cubed plus 2x squared minus 3x plus 1. That is my final answer. Okay. All right. Okay, so polynomial functions and graphs. Turning points, key concept here is that turning points of a function are called relative maxima and relative minima. Okay. All right. Also, you can factor polynomials by using the various common factor, grouping, or quadratic techniques. And the remainder and factor theorems, the binomial x minus a is a factor of the polynomial f of x if and only if f of a is equal to 0. Okay, so those will come up later. And then these are also more key concepts about roots and zeros and things like that. Okay. All right, so back to the problem. So here it says, how many unique real zeros does the graph have? Well, we can see that it crosses the axis, the x-axis, 1, 2, 3 times. Okay, so crosses it 3 times, so that would be C. Okay, and that's it for that problem. Okay, number 8, it says if C of x is 3x squared cubed plus 5x squared minus 4, what is the value of 4C of 3b? Okay, so what that means is you're first going to put 3b in for x, okay? And then once you get that, then you're going to multiply by 4. Okay, so I'm going to rewrite this. So I'm going to do C of 3b first. Okay, so instead of x, I'm going to put 3b. Okay. Okay, and then I'm going to use order of operations to solve here. So I got 3. Now 3 is being raised to the third power, and so is b. Okay, so 3 to the third power is 27, b to the third is b cubed. Okay, and then here I have 5, so again 3 is being squared, that's 9, and b is also being squared. Okay, and then I have, I got to multiply 3 times 27b cubed, that's going to be 81b cubed, and then 5 times 9 is going to be 45b squared minus 4. Okay, now I did this part. This is C of 3b, but now it wants to multiply 4 times whatever C was. Okay, so now I have to multiply everything by 4. So this was 81b cubed plus 45b squared minus 4. Okay, so then I end up with 324b cubed plus 180b squared minus 16. So you have to distribute that to each of the terms. Okay, and this is my final answer. Okay. All right, this is problem number 9. It says to complete each of the following, you have to know how to graph a function, okay? So here is my x value, and then I'm going to be using x cubed plus 4x squared minus 3x plus 1, okay? So when I plug in -4, I get -4 cubed plus 4 times -4 squared minus 3 times -4 plus 1, okay? And then when I do that, I get -64 plus 4 times 16 plus 12, negative times negative is positive, plus 1. And then when I multiply 4 times 16, then add everything else, this -64 and everything, I end up with 13. Okay, so when x is -4, y is going to be positive 13, which is about here. Okay. All right, and then I'm going to plug in -3. Same thing. -3 cubed plus 4 times -3 minus 3 times -3. Oh, this is square over here. Plus 1. So -3 cubed, that's going to give me -27 plus 4 times 9 plus 9 plus 1. And that's when I multiply this and add everything, I end up with 19. So, oh, what happened to my negative 4 was about here, 13, and then negative 3, a little bit higher at 19, okay? Then I'm going to plug in 0, okay? You get 0 cubed plus 4 times 0 squared minus 3 times 0 plus 1. So that's 0 plus 0 minus 0 plus 1, which is 1. So when x is 0, y is 1 right here, okay? And then I'm going to plug in 1. So 1 cubed plus 4 times 1 squared minus 3 times 1 plus 1. And I get 1 plus 4 times 1 minus 3 plus 1. Multiply and add everything or subtract everything together, and I get 3. So 1 is going to be 3. Okay. All right. And then do one more. Do 2. 2 cubed plus 4 times 2 squared minus 3 times 2 plus 1. I end up with 8 plus 4 times 4 minus 6 plus 1. I end up with 19 over here. So that when x is 2, y is 19 up here. Okay? All right. So that means when I graph this out, I'm also going to include negative 5 here. Okay? So this is negative 5 cubed plus 4 times negative 5 squared minus 3 times negative 5 plus 1. So negative 5 cubed would be negative 125 plus 4 times 25 is going to be, and then negative 3 times negative 5 is going to be positive 15, and then plus 1. And this ends up being negative 125 plus 100 plus 15 plus 1. So negative 125 plus 100, that's negative 25 plus 15, that'd be negative 10 plus 1 would be negative 9. Okay, so when x is negative 5, y is negative 9 here. Okay, just to get a better picture here. Okay, so when I do my best to draw this, because it's really hard to draw this on this thing. Okay, I'm going up, going this way, then I'm going down. This, okay? Sorry, that's so horrible. Okay, so then part B, it says to determine the consecutive integer values of x between which each real zero is located. So I can see here, there's a real zero between negative 5 and negative 4. So I'll just put it here. Between negative 5 and negative 4. That's my real zero there. Okay, now this one doesn't really dip below, so that's not going to be a real zero there. Okay, so it just has one real zero. And then it asks for the relative maximum. So if you look at the table, the highest value here is going to be 19, and that's at negative 3. Okay, so the max is going to be negative 3. And then the minimum value is going to be, the relative minimum is going to be about 0.3, okay? Because it doesn't go down below 0, okay? All right. All right, so this one here, it says to factor completely. All right, so when I look at this, I see that there is a y for both of these. So I'm going to factor out a y, and I'm left with 8y to the third power plus x cubed. Now I notice, oh, excuse me. Now these are both perfect cubes, right? Because 8 is equal to 2 to the third power. And then I've got y cubed and I've got x cubed. So I can pull out 2y plus x, and then I'm left with 4y squared minus 2y times x plus x squared. Okay, and this is, we can use the factor of the sum of two cubes. Okay, so this is y, 2y plus x, and I can simplify this. This would be 4y squared minus 2xy plus x squared. Okay. All right, next problem here. It says to solve each equation. Okay, so what I notice here is that I can factor this easily. Okay, I know I have this x to the 4th, so I can do x squared times x squared, and then factors of 28 that add up to negative 11, and when I multiply them I get positive 28. That's going to be negative 4 and negative 7, right? Negative 4, 4 times 7 is 28, negative times negative is positive, and negative 4 plus negative 7 is negative 11, okay? So I set these equal to 0. And so here I would add 4 to both sides. So I get x squared equals 4. So then I can take the square root of both, and I get x is equal to plus or minus 2. Because remember, that could be negative 2 squared, or x could also be 2 squared. So over here, same thing, solve for x. It's x squared equals 7. And then I can take the square root of both, and I get x is equal to plus or minus the square root of 7. Okay? All right, number 17. Okay, we're going to go ahead and go for this one, number 19. Given a polynomial and one of its factors, find the remaining factors of the polynomial. Okay, so if we know that this is one of the factors, we know we can divide this polynomial by this polynomial here, okay? All right, so I'm going to use long division, okay? So I'm going to see if I divide x cubed minus 4x squared plus 10x minus 12, if I divide that by x minus 2, then, which is one of my factors, because I know this times something else is going to give me this, okay? So I'm going to go ahead and do that. Just change colors here. All right, so x times what is going to be x cubed, well, x squared. Okay, I can multiply x squared times x minus 2, and I have to distribute here. So I get x cubed minus 2x squared. So that goes down here, x cubed minus 2x squared. Okay, and I'm going to subtract this, and this is already subtraction, so I add. Okay, so this is 0. X cubed minus x cubed is 0. And then negative 4x squared plus 2x squared is going to be negative 2x squared. Bring everything else down. Now x times what is going to give me negative 2x squared? Well, that's negative 2x. Okay. And then I multiply negative 2x times x minus 2 to distribute. So negative 2x times x is negative 2x squared, which is what I wanted. And then negative 2x times negative 2, that's positive 4x. So this is minus 2x squared plus 4x, but remember I am subtracting here, so I change the signs here. Negative 2x squared plus 2x squared, well, that's 0, and 10x plus negative 4x is 6x minus 12. And then x times what is going to give me 6x? Well, times 6, right? And then 6 times x minus 2, I distribute. 6 times x is 6x, and 6 times negative 2 is negative 12. So I have 6x minus 12, and I have a remainder of 0. So the other factor is x squared minus 2x plus 6. Okay, so this is a factor, and then this is also another factor. All right. So number 21, it says, state the possible number of positive real zeros, negative real zeros, and imaginary zeros of each function. Okay, so first of all, this p of x has degree of 6. Okay, so that means it has 6 zeros. Okay, so it's going to have 6 total zeros. All right, so I can use Descartes' rule of signs to determine the number of possible real zeros, and there is one sign change from here to here. It goes from positive to negative, so that means there is one positive real solution. Okay, so that's one of them. And then we need to count the number of sign changes for f of negative x. So if I put in a negative x for each one of these, for every place I have an x here, I end up with 2 negative x to the 6th power plus 5 times negative x to the 4th power minus negative x to the 3rd power minus 5 times negative x minus 1. So that ends up being 2 times x to the 6th power, it's positive because it's an even exponent, plus 5 times x to the 4th, and then this negative x cubed, that would be negative x times negative, so that would make it a positive x cubed, so still don't have a sign change. And then over here I have negative 5 times negative x, well that's going to be positive 5x, and then I have minus 1. So I only have this one sign change right here, okay? So therefore, one sign change equals one negative real solution, okay? So I've got one positive real, one negative real. So therefore, since there are 6 total, one is a positive real solution and one is a negative, then there are 4 imaginary solutions. Okay, so 6 total, 1 positive real solution, 1 negative real solution, and then 4 imaginary solutions. Okay. All right, so that's it for the Chapter 5 test review. Please call, text, email, or stop by my office hours if you have any questions. I am here to help, okay? You have a great day and good luck on your test.